Hello and welcome to my world of conversation around math topics. My name is Amber Soto. I'm the Director of Mathematics for iLead Schools, and today's topic is solving systems of linear equations by using the substitution method. So I want to start by reading you a story. Here we go. Mrs. Sunshine was so excited for her upcoming show. She had worked so hard to build something she was proud of. Her learners went around talking about how Mrs. Sunshine was going to be famous. But Mrs. Sunshine was a very humble soul and she didn't want the fame. She just wanted to make a difference in all the world through her art. Mrs. Sunshine was inspirational to us all. Excuse me, said Mrs. Sunshine. What? That isn't part of the story. Are you talking to me? I'm just the narrator. Yes, I'm talking to you, continued Mrs. Sunshine. I will prefer it if you call me by my first name. Daisy. Okay, so I guess I could put Daisy anywhere I see Mrs. Sunshine in the story. Would that work? And then we could just retell it with Daisy in it. Of course, thank you, said Daisy. Now, how does this relate to what we're doing? So first of all, thank you for bearing with me through really bad accents. But also it was important for you to recognize that all we're doing is we're taking two things that are essentially the same. Daisy and Mrs. Sunshine is the same person, just a different name, and we're replacing one with the other. The same is true in math. When we use the substitution method, we take two things that are equal to each other or equivalent, and we can always put one in the place of another. So let's try a simple example with that. If I tell you that x equals 5, and then I give the expression 2x plus 1, what I'm saying to you is that anywhere you see x, you can put a 5 in its place because they're equivalent. They're the same, okay? So here in this expression, we see an x, which means we can put a 5 in its place. Now be very careful. One of the biggest mistakes learners make is they see that as 25. Let's go back real quick and look at how are the 2 and the x related. Okay, what is the operation happening there? Well, anytime we don't see a sign in between, so there's no plus between the 2 and the x, no minus, no multiplication sign, no division. By convention, we know it's multiplication. So whenever a number is next to a variable, we know that it is multiplication by convention. So this is not 25, this is 2 times 5. So let's pop it back in with the parentheses so we can see that differentiation. So 2 times 5 is 10, plus 1 equals 11. We solved our problem using substitution, but that was just one equation. Now we're going to do a system because remember, in a system, it's more than one. Both of these are equations of lines or linear equations, and there's 2 of them. So we have to substitute one into the other to be able to solve it. But which one do we choose? And the answer is you can choose either. And I'm going to show you that later on, how if I choose 2 different things, the answer will still come out the same. But right now, let's just focus on the substitution. We'll get there. And I want to pick the easiest. So I see here y is already solved for 3x. We already have y by itself, and it's telling me y equals 3x. So anywhere I see y, I can put 3x in its place. So I see a y up here, I can pop 3x in its place. And now we solve this. What's 2x plus 3x? We combine like terms, it's 5x. So we get 5x equals 5. And then remember, when it's multiplied, we divide to undo. So divide both sides by 5, and we would get x equals 1. Now you may think we're done because we got to a final answer, but remember, when solving a system of linear equations, you're always going to get one of 3 outcomes. Because remember, a solution is where the point is true on both lines. So it's either going to be where the 2 lines cross and you'll get a point, or it's going to be no solution because they never touch because they're parallel, or it's going to be infinitely many solutions where they're on top of each other, so they touch everywhere. They're the same line. So there's all kinds of solutions. So we didn't get any of these 3 things. We got x equals 1, but what does that mean? Well, remember, a point is always in the form xy. So we have our x. We just need to figure out what our y is. So we now have a situation where I'm telling you x equals 1. So again, anywhere I see x, I can put 1 in its place because I told you over here x equals 1. So you can pick whichever equation you want. If you don't believe me, try the other one. Once I've done this one, you'll see it's the same, but I'm going to go with the easy one. So y equals 3x, I can put a 1 where there's x, because over here it told me x equals 1. So pop a 1 there. Remember, this is not 31. This is 3 times 1. So y equals 3. And so my solution here, x was 1 and y is 3. Now I have a point. That is my solution where those two lines would cross. If you were to graph these, you see they'll cross at 1, 3, the point 1, 3. Okay, but sometimes it won't be that straightforward. Sometimes we won't have one of the equations be already solved with y equals. So we got to do some work. I call it algebra acrobatics, to kind of move stuff around so that we can isolate one of the variables and that it'll work. So we have to decide which one we're going to do. We have to choose wisely. Now, again, there are several different variables we could solve for here. And on the next slide, I'm going to do the exact same problem with a different one. So I'll show you that that's true. But for right now, I'm going to get this x by itself. So I'm going to do a plus y, so this will cancel. But remember, we have to balance on the other side of my wall to keep that at equal sign balanced. So on the left side, we just have x left over, and on the right, we have 3 plus y. I'm going to pop that over here for now so we can hold on to it. If you put y plus 3, that's fine too. Remember, addition is commutative, so we can flip that. So it's telling me x equals 3 plus y. Anywhere I see x, I can put 3 plus y. Now, it's important to note that a lot of times you'll rearrange one problem and then put it back in the same problem, and that won't give you what you're looking for. So pay close attention. The problem that you rearranged, this bottom one is what we moved around. Now you're going to take that and pop it into the other one that you didn't touch. This top one we didn't touch yet. So I'm going to put that down here. Notice this is the same. 4x plus y equals 2 is the same as 4x plus y equals 2. I just gave it more space here so that we can pop this 3 plus y on top of that x. Put it right in place of the x. So again, because we have the parentheses, this is 4 times 3 plus y, and we use distributive property. 4 times 3 is 12. 4 times y is 4y. So we're going to get 12 plus 4y, and then we didn't touch this, so it comes down plus y equals 2. Now we combine like terms. 4y plus y is 5y. So we have 12 plus 5y equals 2. Now we're going to subtract 12 from both sides so we can get this 5y by itself. So minus 12 makes that go away. Minus 12 gives a negative 10 there. And then we're going to divide both sides by 5, because 5 times y, we need to undo that. So 5 divided by 5 would give 1y, or just y, and negative 10 divided by 5 would be negative 2. Now, I'm not going to go too much into the solving because I want to focus just on the substitution method. Hopefully you're able to solve at this point, but if not, we have another video for that. Okay, so again, we're not done. We need a point. Don't ever feel like you're stopped here. We need x, y. At this point, we have y as negative 2. In the last video, we had x. So now we need to go back and solve for x. Y equals negative 2. So again, we can pop this into either equation. I choose x minus y equals 3. So now I know y can be negative 2. That's what it told me down here. So I popped it in its place. So x minus negative 2 is the same as saying x plus 2 equals 3. And now we subtract 2 from each side so that we can get x equals 1. So now we have x is 1, y is negative 2. We have our point. Now we're done. Okay, pay attention to these equations. 4x plus y equals 2, x minus y equals 3. I'm going to solve the same one, and the answer is going to come out to, again, 1 and negative 2. So look, 4x plus y equals 2, x minus y equals 3. They're the same ones. But this time, before we solve for the x, now I'm going to solve for this y. So here's my wall to keep the balance on both sides of the equal sign. I'm going to subtract 4x from both sides. So this goes away, and I have just y on the left. So let's pop it over here, and 2 minus 4x on the right. Okay, now we rearranged the first equation, so now we need to pop it in to the second equation. So we have y equals 2 minus 4x. Anywhere I see y, I can put 2 minus 4x in its place. So let's do that. Here's x minus y equals 3, and here's my y. 2 minus 4x right there, okay? And remember, this came from here. I just used this equation. So now remember, when we're distributing, this is not just -2, it's minus this whole thing. So it's -2 and it's minus -4x. So that's going to be plus 4x. So let's write it. X we didn't touch, -2 plus 4x equals 3. So again, we do our math from this point. X plus 4x is 5x. This is all regular solving equation stuff. -2 equals 3. Plus 2 on both sides. So this goes away. 3 plus 2 is 5. Now divide it by 5 on both sides. So I'm going to get x equals 1. I'm not done. I need a point. So I'm going to plug 1 back into one of these two equations. I choose the bottom one because it's easier. X minus y equals 3. Now remember, on the last slide, I plugged a -2 in for y and we solved there. This time I'm going to plug a 1 in for x. So I'm doing the opposite this time. So now subtract 1 from both sides. I'll get a -y equals 2. And we want to change this negative to a positive. So we change all the signs. Y equals -2. And look, we got the same answer. So I don't want you to be afraid that you're doing it wrong. As long as you are doing legal math moves, you may solve for one variable. Somebody else may solve for another. That's okay. You'll come to the same answer as long as you're doing legit moves. There's one last scenario I want you to consider, and that is this. What if I had this where 2y and 2y are the same? Let's say I solve to get the 2y by itself instead of the x. We're kind of getting into this mindset that we always need one letter by itself, and I want to shake that a little bit. So here's the top equation. Let's pop this over here. The x's went away, so I have 2y on the left, and I have 6 minus x or -x plus 6. You can flip them on the right. Since I messed with the first equation, I need to pop it into the second equation now, this one. So I'm going to bring this down here. 3x plus 2y equals 14. You see 3x plus 2y equals 14, same thing. But in this case, I said 2y equals -x plus 6. So that means anywhere I see 2y, I can put -x plus 6. I don't want you to think it always has to be one letter. If two things are equal, two things are equal. You can replace them. So now let's follow through with this. 3x, now when the positive distributes, it just leaves it the same. So 3x minus x plus 6 equals 14. 3x minus x is 2x. And then I'm not going to talk you through it. You get how to do it. You do the solving of the equation. We get x equals 4. Again, we know we need the point. So we have 4, but we don't know the y. So we pick whichever of these equations we want. I take the easier one. And now I tell you x equals 4 down here. So that means here's my x. I'm going to pop a 4 in there. Subtract 4 from both sides to get 2. And then I have 2y equals 2. So I divide by 2 on both sides and I get y equals 1. So I wanted to show you that so you could see you can plug anything in. It doesn't have to be a single letter. Okay, before I go, I just want you to remember, this is a reminder of the 3 possible outcomes when solving systems. A point, which is all that we've done today. Every single problem we found a point. Infinitely many solutions or no solutions. So this is what it looks like. For a point, graphically, if you were to graph them, it means that they intersect at that point. That's the answer. So if you did it algebraically and you solve and get the point, you put it on the graph, it would be the same point. Usually you get a variable equal to a number, and that's usually x or y, but it doesn't matter. You can have any letters there. So for example, y equals -3. That's something you could get, like we got x equals 1 or, you know, whatever it was. That's when you know it's a point. But it's important to note, you need to remember to always plug it back in to one of the original equations to solve for the other variable so you have your full point. Okay, infinitely many solutions. Graphically, we already know that means the 2 lines are on top of each other. They're touching and they have many, many solutions. But algebraically, we didn't talk about this, you will get a true statement. So when you solve your algebra, when you plug one equation into the other and solve it out, you'll end up getting something like 5 equals 5. That's true. That means no matter what you plug into the variables, it's always going to come out to 5 equals 5. It will always be true because it's infinitely many solutions. And what no solutions look like, graphically, we know they're parallel, but algebraically, you'll get a false statement. So when you solve, when you plug one into the other and solve it out, you'll get something like 3 equals 5. That's not true. And so no matter what you plug into the variable, it'll always come out 3 equals 5. So you know there are no solutions that could make this work. Okay, so we didn't see any of these two. I wanted you to see what they look like in case you come across one. But with that said, I've got nothing else for you. I don't want to make this video too long. I sincerely hope this helped you. And with that said, happy mathing, everyone.